In this video, we're going to continue talking about heating curves. And so I'm just going to redraw our graph here. In the other video, we kind of went from the start to A, from A to B. And now we have to go from B to C, C to D, and D to E. And so just to recap, the solid, right, and I'll just write this. This is a solid here, and I'll just tell you these are liquid, this is a liquid, and this is a gas. The solid, we add energy to it, its temperature increases, so most of the energy is going into kinetic energy. The slope of the line is determined by the specific heat of the substance. At a certain point, it reaches kind of this maximum temperature that it can have while being a solid. And that's here, and that's the melting point. And once it gets to the melting point at A, that's the kind of the hottest a solid can be. This solid can be. And the more energy we add, the more the potential energy of the molecules increases. So this is not going to kinetic energy, so it's not increasing the kinetic energy, and the temperature is not increasing. And what it's doing is it's changing the state. So from A to B, you're melting that solid into a liquid. And then so here, it's kind of solids and liquids together. At the very end, at B, you've gotten to a place where it's all liquid now. And to go from B to C is also kind of just like from S to A, is liquid is increasing in temperature, which is kinetic energy. And again, the slope will depend on the specific heat. Then we get from C to D. This is analogous to A and B. Right? This happens at a specific temperature, the boiling point. And this is like the hottest a liquid can be and still be a liquid. Right? It's the fastest that the liquid molecules can move and still maintain their intermolecular bonds. Any faster, and they have to be a gas. So when we add energy from C to D, you can see that the kinetic energy is not increasing, right? Because the temperature is not going up. So just like from A to B, it's going into potential energy. So this is a liquid that is starting to boil, right? So it's boiling, so it's starting to vaporize, I guess, to become a gas. And the energy is going into increasing potential energy and not kinetic energy. And then when you get to D, you've now all the liquid has boiled off into gas, and now you're stuck with some gas. So then from D to E, you have your gas, and you're just adding energy, and it's adding to the kinetic energy. And so it's just increasing in temperature. And that is a heating curve. And you can see that there are two really important temperatures, the melting point and the boiling point, and those reflect kind of like the fastest the molecules can move while still being a solid or while still being a liquid. You have three stages of the solid, liquid, or gas increasing in temperature, right? So that's when we're adding energy and the energy is going to the kinetic energy. And we have two plateaus, that would be A and B and C and D, right? And C and D is liquid and gas existing together. And during the plateaus, the energy is going to potential energy and not kinetic energy. And increasing that potential energy is what's converting some of that solid to liquid or some of that liquid to gas. Now, if we thought about this graph, but in reverse, and we started with E, and went from E, D, C, B, A, S, it would be a cooling curve, and it would represent what would happen as we had a hot gas that we let cool down, right? It would get cooler and cooler, and it would eventually turn into a liquid. And as it's condensing into a liquid, its potential energy would be increasing, and so on and so forth, right? And you just kind of go backwards. And the next video we'll talk about heat of vaporization and fusion.